Hi everyone, welcome back to Life Technologies channel and thank you for watching. This is a continuation of our Huawei Lab simulation series where I've been demonstrating how to implement different networking technologies or different networking protocols on Huawei routing and switching devices. So in our today's episode, we'll be focusing on how to control OSPF DR-BDR election process on Huawei routing devices. We know OSPF had the concept of DR and BDR, which is a very important concept in the operation of OSPF protocol. But before we dive into the lab simulation, we need to have a good understanding of some key concepts of DR-BDR. The first thing that we need to understand is what are the DR and BDR, and why do we need DR or BDR in OSPF. And another thing that we also need to understand is how do we elect the DR or the BDR for OSPF protocol. So the protocol has its own mechanism of electing the DR and the BDR. But then sometimes the network administrator wants to have control of which router becomes the DR and which router becomes the BDR. So sometimes you need to manually control the DR and BDR election. So these are the main concepts that we'll be discussing and demonstrating in our lab simulation. So to start with, the DR and the BDR. The DR stands for designated router. The BDR stands for backup designated router. The DR and the BDR, for me, it's similar to the route reflector in BGP. The DR and the BDR are mainly in charge of exchanging the update information for OSPF protocol. So we have the DR, which is the designated, but then sometimes some issue may happen to the DR. So that's why you need the BDR to be able to take over in case the DR has gone off or there is a disconnect between the DR and the other routers. So we'll have the DR, we'll have the BDR. Then the other routers will be DR other. So the DR and the BDR will be in charge of exchanging update information in the network. This is for OSPF, the update information for OSPF. So with the DR and the BDR, we don't need to establish adjacent relationship among all the routers in the network. We don't need meshed adjacencies in the network. So this one, the DR and BDR is helping us to reduce the number of OSPF adjacency on a large network. So normally, if you have n routers in your network, the number of adjacencies will be n minus 1 divided by 2. So you can see the number of adjacencies that you have to establish in the network. If you have 100 routers, you may end up having many adjacencies. The service provider network mainly has many routers, maybe thousands or 10,000 of routers. And if you are running OSPF, maybe let's say in just one area, it means you may end up having so many adjacencies in the network. So that's why we need the DR and the BDR to help us reduce the number of OSPF adjacencies on a large network. So this one even speeds up the network convergence because you don't need to send your information to all the routers. You only need to advertise to the DR and the BDR, which will be in charge of advertising to the other routers. So the DR and the BDR are only elected on multi-access network. These are broadcast network and non-broadcast multiple access networks. So on a point-to-point network or point-to-multipoint network, we don't elect the DR and the BDR. We only elect on multi-access networks, which are the broadcast networks. And then with the concept of OSPF, DR and BDR, our routers have different functionalities. So as we've mentioned, we have the DR and BDR. How about the others? The others, we call them the DR other. So we have three types of routers. We have the DR, designated router, BDR, that is the backup designated router. Then we have the DR others. which don't establish adjacencies between themselves. So we only establish adjacencies between DR, BDR, and DR others. DR others don't establish adjacencies. So when you have the DR and the BDR, there are some election rules that are followed by the router. First, the first rule is we are looking at the DR priority. So if you have two routers and these routers have different DR priority, we select the router with the highest DR priority as the DR. Then the second router with the second highest will be the BDR. And on Huawei, the default DR priority is 1. So it means if you haven't made any configuration changes on our router, all the routers will have a DR priority of 1. So we may not have a tiebreaker if we haven't made any changes on the DR priority on any of the routers. If we don't have a tiebreaker for the DR priority, the second criteria is to select the router with the higher OSPF router ID. So the router with the highest OSPF router ID will be selected at the DR, and the second one will be the BDR. So if you are having a match, all the routers having the same DR priority, we look at the second criteria where we are now checking the OSPF router ID. And remember, many times it's recommended that you configure a router ID on the routers manually. When you are configuring OSPF, you have to specify the router ID, which will be used to form the adjacencies. So these are the two criteria. Number 1, the DR priority. Number 2, we are checking the router with the highest OSPF router ID. And with the OSPF, DR is non-preemption, which means if a network is operating, you have elected the DR or the BDR, and then you add in another router. This router could be having a higher DR priority, or this router could be having a higher OSPF router ID. That router will not become the DR. The existing DR and the BDR will continue to be the DR and the BDR unless you have reset the OSPF process and then the adjacency has been reestablished again. That's when you will have the DR and the BDR re-election. But if the network is operating okay and you already have the DR and the BDR, there will be no new election to select the DR and the BDR. So these are some key concepts that you need to have an understanding for you to be able to fully understand the operation of OSPF protocol. So on our lab simulations, as you have seen on the topology, we have 4 routers connected on a switch. So these are broadcast network, and we are configuring OSPF process 10 in area 0 and advertising the networks, first connecting to the interconnecting different routers to the switch and the network going to the PCs. So we have a broadcast network and we'll see how the DR and the BDR is elected on this network. So for the configuration, the first part of configuration, we are configuring the system name and the interface IPs. So we have interface loopback 0. We assign the IP address based on the router number. And then we are also configuring the interconnected interfaces to the switch and to the PC. So once we have configured the interfaces on router 1, we do the same on router 2, router 3, and router 4. So we have our interfaces configured with IP addresses, both the physical interface and the loopback interfaces. The second part is to configure OSPF on all routers. So we need to create OSPF process 10. We are configuring the loopback 0 as the router ID. Remember, the router ID will also be used in DR and BDR election. And once you've configured the router ID, we are creating area 0 and advertising the networks connected to the router. So we advertise loopback interface and also the network going to the switch and also the one going to the PC. So once we have finished configuration, we can now verify our OSPF adjacencies on different routers. So remember, we haven't done anything on the DR or the BDR election process. But as I've mentioned before, the router themselves have a mechanism of selecting the DR and the BDR. That's why we have mentioned about the DR priority and the interface IPs. The one with the highest will be selected as the DR. So if we log into the lab, this is the lab as shown before. If I check on R2, can start with, I will clear it. If I display OSPF peer, you can see that on R1 we have 3 peerings. And these 3 peerings, we have the DR, which is 10.10.4. So router 4 has been elected as the DR, and then router 3 has been elected as the BDR. So this is router 2. You can see that on router 2 we have 3 neighbors or adjacencies. We have adjacency to router 1, adjacency to router 3, and adjacency to router 4. So if I display OSPF interface, you can see the priorities. The priority is 1, priority is 1, so the default priority is 1. And you can see that for this one, it's DR other. And then we also have, this is connecting to the PC, so this is the DR for that segment, because it's a broadcast network, so we end up having the DR, but for point-to-point, we don't elect the DR and the BDR. So as you can see, this one, all the priorities set to 1. Sometimes OSPF, the adjacent, remember I mentioned that DR and BDR election is non-preemption, which means, for example, if we have 2 routers, the adjacency between router 3 and router 4 comes up faster compared to the adjacency between the other routers, then the DR and the BDR on this broadcast network will be between the 2 routers. And if these 2 comes and adjacency is established, we won't have a re-election process unless we do a reset for the OSPF process on all the routers, and then it comes up at the same time. So as on R3, we can also verify that we have display OSPF peer. On R3, we also have 3 peerings. You can see this one, it's R3, remember it's the BDR. R3, yes, R3 the BDR, so you have the DR, the state is full, the state is full, state is full. If we display OSPF interface, we have the DR, we have the BDR. If I do, let me check on R1, display OSPF peer. So you have 3 peerings also. Display OSPF interface. Bubbles. You can see more details about these interfaces. So by default, we are selecting the DR and the BDR either based on the IP address, the router with the highest IP address, or the router that first established the adjacent before the others. Remember, when I'm configuring the lab, I may not be able to configure OSPF on all the routers at once. So it will come up at different timestamps. But then, if I need to control, let me say, for example, I want R1 to be my DR. How do I go about it? This is very simple to implement. I just need to log into R1, and then I can specify the OSPF DR priority on this interface gig00 to be 100, and then that will be we will now have R1 having the highest DR priority, and it will be selected as the DR. But remember, it all depends on the adjacent establishment timestamps. So I've configured the priority of 100. For us to be able to do the re-election process, I will shut down this switch and bring it up again so that we have OSPF adjacent is re-established between the routers. So if I stop this device and give it time so that we have OSPF adjacent these, the timers will go down and then the OSPF adjacent will be re-established. So if I check on R4 just to verify that the adjacencies are down, OSPF peer, we don't have the OSPF peer. On R3 we'll do the same, display OSPF peer, we don't have an adjacencies. So now I can bring up the switch and verify that we will have a new DR elected on the network. So we wait some time for the switch to come up, then we can verify that our peerings come up and we can see who is elected as the DR. Still not yet. So remember, we have the STP running on the switch, so it will take some time for it to converge, and then once it converges, we can have communication between the routers, and then we can have the election of the DR and the BDR. So you can see that as much as we have configured the DR and the DR priority on R1, we are still having R2 selected as the DR. And the reason is that adjacency between these routers came up faster. So R2 and the other router, the adjacency came up earlier compared to, you can see this one, the neighbor up for 3, 6. So these adjacency came up faster, so we had the election process completed when the adjacency was being established on R1. So as much as we have configured the DR priority to be higher, we still don't have R1 elected as the DR because yes, it has a higher priority, but remember, OSPF doesn't have there is no preemption for the DR and the BDR. But as you can see, this is how simple it is to implement DR and BDR election on OSPF, like how to control the DR and the BDR selection process. So thank you for watching again, and I think this is the end of our lab simulation today. Remember, the configuration steps are simple. You need to assign addresses, and then you need to configure OSPF, and then on the interface for the router that you want to be the DR and the BDR, you can configure the OSPF DR priority. Thank you for watching again. Thank you for supporting our channel, and please, if you have any question, you have any comment, please leave your comments in our comment section, and subscribe to our channel for more upcoming videos on Huawei lab simulations. Thank you.